Hello everyone, I'm Kelly Chin, and the research is the association between ketosis and fertility parameters in Dutch dairy cattle. So before let's start talking about the association, I will give you a little bit background knowledge. So when the cows give birth to a calf, it will have an imbalanced energy intake and energy demands. And some cows, they can adapt very well to the imbalanced energy status. However, some cows, they cannot adapt the imbalanced energy status very well. So then they develop ketosis or hyperketonemia. And hyperketonemia was found to have a negative influence on fertility performance. And most of the study measured blood BHB, and only a few studies have used milk BHB to detect the hyperketonemia. And so the end of the study is to evaluate the association between milk BHB dynamics and the fertility parameters at cow level. This is a retrospective observational cohort study. Around 5,000 dairy cows from 38 Dutch dairy herds are included in this research. And all the dairy farms, they have the automatic milking systems. So once the cows go into the milking systems, the machine can automatically collect some of the milk sample from the cows and go into an analysis. So a more frequent sample can be done by the machine, and therefore there is a time series measurement of milk BHB level and the reproduction events. And the reproduction events are defined by the milk progesterone level detected by the machine. And here we just use fertility parameters as the outcome. Yeah. And so we want to see whether the certain fertility parameters as a function of milk BHB dynamics and with some potential confounders such as herd size, lactation, parity, milk production, etc. will affect the fertility performance. And this is the data we have. We have the farm number, cow ID, and lactation. Lactation here means the parity of the cows. And also we will have the birth date of the cows and the calving dates of the cows and the number of insemination of the cows after calving and the date when the cows get pregnant again. And the DFC last insemination is the days in milk when the cows was recorded to have its latest insemination. And the mean BHB here means the mean milk BHB level of the cow within the first 60 days postpartum. And the number of ketotic cows means the number of times when the milk BHB level per cow are over 0.08 micromolar per liter. Here I first just define the milk BHB level over 0.08 micromolar per liter as hyperketonemia. And the keto cow is a dichotomous variable, where one means the cows has at least once detected milk BHB value over 0.08, and 0 means the cows has never been detected as BHB level over 0.08. And DFC first keto BHB is the variable where the days in milk when the cows was first detected as milk BHB level over 0.08. So firstly, I would like to know how many cows in each farms. And here we can see that we have 38 farms, and The smallest farm includes only 49 cows, and the largest is Fertility. It has 438 dairy cows in this study, and the mean number of the cows included in this study is 133 cows. Also, I want to see the lactation distribution of these 5,069 cows. And here I can see that most of the cows are in their first lactation, and the maximum value of lactation is 12. There are 2 cows in their 12th lactation, and the mean lactation is 2.7. And now I want to see the mean milk BHB level among those 5,000 cows. So on the left hand side, the scatter plot is the cows that each cow's their mean BHB, and the red line is the threshold where the mean BHB level is 0.08. So above the red line, the cows has a mean milk BHB level over 0.08. But this plot is not that clear. And on the right hand side, the keto count 0 means the cows has never been detected as over 0.08, and 1 means the cows has at least once been detected as ketotic cows. So here we can see that the mean milk BHB level among the cows who has been detected at least once as ketotic has a very wide range of the BHB value. I think these 2 plots are not very clearly show the distribution of mean milk BHB level. But I want to know how to draw a better plot for this. And here is the outcome variable. I use the number of insemination for each cow as the outcome variable. So here I know that there are around 400 cows are 0, which means for around 400 cows they are not inseminated yet after late calving. And the highest is 72, and so there is 1 cow which has been inseminated 72 times after its calving, and the mean insemination times is 5.884, and there are 115 cows that we don't know how many times they have been inseminated after calving. So this is the outcome variable. So let's go back to the research questions, is to find the association between ketosis and fertility parameters. And to simplify this research questions, I just set the mean milk BHB level over 0.08 as the ketosis, and the reproduction events is the number of insemination. And there are a lot of factors that can affect both the milk BHB level and the number of insemination, such as parity, age, and days in milk, and the milk yield, and even some of the factors such as seasons, feed, farm type, and farm size are potential factor that would affect the milk BHB level and the reproduction events. and some of the variables are not provided in the dataset. So the simplified research question is the number of insemination before pregnancy as a function of mean milk BHB level and the first day in milk when the BHB level over 0.08 micromolar per liter, and to see whether lactation will have different results concerning the number of insemination. Lactation is also very important in this model. And there are a lot of models can be used in this data set. However, I think since the distribution of the outcome variable and it is a count data which counts the number of inseminations of the cows, so I would prone to use Poisson model to do the analysis. Thank you for your attention and feel free to ask questions.